This is lesson 2.9 and it's about combined and joint variation. A combined variation equation has two or more independent variables, and the independent variables can have any positive exponent. To find k in a combined variation model, use the same strategy as in a variation problem with one independent variable. So we'll think back to lessons 2.1 and 2.2 when we had those 4 steps, and we're going to use that same strategy with a combined variation equation. An example of a combined variation equation could be y equals k times p divided by x, where you have a direct relationship between y and p and an inverse relationship between y and x. So that's combined. So it has both direct and inverse. So in step 1, when you're solving these types of problems, you're going to find one example that relates all the variables at the same time. In other words, you're going to write out an equation for all the variables. Step 2, you're going to substitute what you know. Or what you're given. And then step 3, you're going to solve for k. So it's really the same process as you've done with direct variation equations and inverse variation equations. It's just it's going to have a combined. It's going to have both direct and inverse in it. So we'll go through an example so you can see how this works. Mario is pedaling a bike at 80 revolutions per minute, or 80 RPM, using a front gear with 35 teeth and a back gear with 15 teeth. At these settings, he's traveling 14.5 miles per hour. Use the combined variation equation S equals K times R times F divided by B. And there you can see we have direct and inverse in that same equation. So some of the variables are related directly to S and some are related inversely. So S represents the speed of the bicycle, R are the revolutions per minute, F are the number of teeth on the front gear, and B are the number of teeth on the back gear. To describe how his speed would change if he increases pedaling to 100 RPMs. Okay, so if we think back to that step 1 we just saw, we're going to find an instance where, or an example that relates all the variables, and we have it already. So step 1, we're going to say S equals K times R times F divided by B. So R and F are directly related to S, and B is inversely related to S. Step 2, we're going to substitute what we know into this equation. And then we're going to solve for k. So what do we know? We know that, well, in this case we got to look down. We know that he is traveling 14.5 miles per hour. So his speed is 14.5 miles per hour. He has a front gear with 35 teeth up here. So F equals 35. He has a back gear with 15 teeth. B equals 15. And now we can solve for k using all that information. So we know his speed is 14.5, and we're plugging it all into that equation, equals k times R, and in this case R is 80 revolutions. We forgot to write that one. R equals 80 times the front teeth, which we said was 35, all divided by those back teeth, which is 15. We can solve for k by doing that math, and we should get k equal to 0.078. Now if we do like we did solving those direct variation and inverse variation equations, we can use that k value and plug it back into that original equation, and then we have a combined variation equation that we can use. So we can say, and I'm just going to do the work down here, S equals 0.078 RF divided by B. Because now we solve for K, and we just put it in there. So then they ask, in this question, describe how his speed would change if he increased his pedaling to 100 RPMs. So now we need to figure out what happens to his speed if his revolutions changes to 100 RPM. So speed equals 0.078. This R is going to be 100 now. The front teeth didn't change. They're still going to be 35. We still have the same bicycle. And the back teeth didn't change. We still have 15 teeth on that back gear. So our speed is 18 miles per hour. So we went from a 14.5 mile per hour speed to an 18 mile per hour speed when he increased his pedaling to 100 RPMs. Okay, let's do example 1B. A bicyclist is pedaling at 85 RPM. So we know that R equals 85. A front gear with 39 teeth, so F is 39. Back gear with 13 teeth, so back is 13, or B is 13. And then it says at these settings she is traveling 21 miles per hour, so speed equals 21. Describe how her speed would change if she decreased her pedaling to 60 RPM. Well, first we want to write that general variation equation. And it is S equals K times R times F divided by B. And they actually gave that to us. So that's that combined variation equation because we've got direct and inverse in one equation. Now let's plug in what we know into that equation. So we can say speed is 21 equals K times revolutions. She was pedaling at 85 RPM, so we should have put 85. Oh, we did put 85. There it is. 85. Front gear had 39 teeth, and the back gear had 13 teeth. We solve for K, and we should get 0.0824. That's our K value. Okay, now we're going to write that equation using that new K value. I'm going to do the work down here. So we can say S equals 0.0824. I just plugged in that value for K times R times F divided by B. And then they want to know how her speed would change if she decreased her pedaling to 60 RPMs. So now we're trying to solve for speed now, and we have 60 RPMs. Our front teeth, we still have 39, and our back teeth, we still have 13. So our new speed equals 14.8 miles per hour. So she went from 21 miles per hour to 14.8 miles per hour just by decreasing her pedaling to 60 RPMs.